A very warm welcome to Adroit Recycling. They've very kindly agreed to provide us with a presentation. Nice to see a big group of Adroit Recycling. So a warm welcome to the Essex Concrete Society. The presentation is, I think we've got a double act going on this evening. It's going to be led initially by Steve Allison from Adroit Recycling, and then with Dr. Alan Richardson doing the cabaret in the middle. Without preempting what they're going to present us with, I'll hand you over first of all to Steve.
Thank you very much. Thank you, folks. As I was just said, my name is Steve Allison. I'm here from Adroit Recycling. And first of all, I'd like to thank you for giving us the opportunity to come and speak to you today, this evening. To tell you a little bit about our products and about our company. And hopefully by the end of the presentation, you'll be interested in talking to us further about possibly working with us on a commercial basis. I'm going to tell you a little bit about how Adroit Recycling can hopefully save you money, make you money, and also improve your green credentials. And then I'm going to hand over to my colleague, Dr. Alan Richardson from Northumbria University, who will tell you some of the more technical details of our product and his research into the use of rubber in concrete. I'm going to start by giving you a brief summary of what I'm going to talk about. I'll then move into the main part of the presentation, and then I'll hand over to Dr. Allen. I shouldn't be here for more than about 10 or 15 minutes or so, which will give us plenty of time to listen to Dr. Allen's presentation, and then for any questions and answers that you've got at the end. Okay, first of all, I'm going to tell you a little bit about Adroit Recycling, who we are and what we do. I'll then move on and tell you about our developments over the last year or so, which, considering we've only been around for about a year or so, I hope will show you how keen we are to be a major player within the industry. I'll introduce you to our products very briefly and tell you a little bit about our stakeholders. Again, you'll see that we have already made some big moves within the industry and already talked to some big players. I'll move on to tell you a little bit more about our products and how we hope you can benefit from them before I hand over to Dr. Allen from the university for the more technical cabaret part of the presentation. Can you have technical cabarets there? We'll find out in about 10-15 minutes. So, Adroit Recycling. Well, Guy, our managing director, who is here with us this evening, and the founder of the company, has been working on this project for the last year or so. Guy's background is in construction. He has a passion for the environment and a passion for commerce, two passions which I'm sure most of you in the room here share. Wherever possible, Guy's construction projects made a commitment to sustainability, using local labour, using recycled products, and producing environmentally friendly business accommodation and housing accommodation. And Guy more recently has been working on establishing Adroit Recycling Limited. We are a new British company. We are based in South London, but our manufacturing plant is in Wales. Our main manufacturing process is the recycling of vulcanised rubber. That is end-of-life tyres and waste rubber products, using state-of-the-art third-generation technology to produce premium quality rubber, steel, fibres and textiles. A recycling plant will be the first of its kind in the UK, there's no other before us, and one of only 40 across the world. It's energy efficient and it has less noise pollution than traditional plants. The plant works at ambient air temperature with no liquid nitrogen. It has a constant wear-independent throughput and low maintenance technology and low noise emissions. We are a green company, we are committed to sustainability, and we aim to protect the environment, to reduce waste and ensure a lower carbon footprint and a more sustainable future for UK industry. Our manufacturing and recycling processes emit no waste products. In terms of developments to date, we have secured a site for our plant in South Wales. We have a T8 exemption in place with our bespoke licence granted very, very shortly. That is currently going through the bureaucracy of the Welsh Government. We have a pre-contract agreement with our German partners to purchase and construct our selected plant with a 6-month lead-in time. And the plant will be able to recycle 2.5 tonnes of rubber per hour and approximately 1 million tyres per year. We're making a £4 million initial investment, and we have the support of UK banks, the UK government, the Welsh Government Agency, and also the Welsh Development Agency. We have verbal agreements in place with over 90 suppliers of waste rubber and tyres, with many more in the pipeline. And we have extensive interest already in our products across a range of industries, including one international concrete maker who would like to purchase all of our steel products and some of our other products for the first year. We have the capacity to collect and recycle over 1 million end-of-life tyres in the UK, plus other waste products, using our fleet of biodiesel-fueled, environmentally friendly vehicles. Using our state-of-the-art third-generation technology, we will produce premium rubber granulates, premium rubber powder, high-quality steel, fibre and textiles, and I think we've got some samples of our products in the boxes in front of you. Our rubber products can be used for a multitude of industrial uses. We can use for new tyres, floor coverings, mats, footwear, UV sealants. We can use it for UV, elastic sealants, sports running tracks, astroturf, road construction, concrete and asphalt. And we believe our MRP to be of much higher quality and purity than much of what the industry is using at the moment. We will sell it at an attractive price that is cheaper and more environmentally friendly than virgin rubber. And in terms of our initial pricing, we're looking at selling our MRP products at a range of £120 to £250 per metric tonne, our steel at £170 per tonne, and our textiles and fibre at £50 per tonne. Last year, over 85,000 tonnes of recycled summer rubber was used in the concrete industry, and we believe that our products to be comparative in price and much better in quality than that is currently in use. And I hope again you'll see that from some of the samples that we've got in front of you today. Some of our stakeholders, well, the Welsh Government Assembly, the Welsh Development Agency and the Welsh Environment Agency are very much supporting and fully behind our project. We've developed strong links with them, we've met with them regularly, they visited our site. We have confirmed that planning permission is on its way and that the development grant is going through the bureaucracy at the moment. They see that the project will bring to them local business, local income, employment and jobs to the area. It will help them enhance their local recycling. It will help them reduce their carbon footprint, reduce fly tipping, reduce illegal storage of tyres, and the consequent risk of fire and pollution and wastewater that's connected to that. We are developing links with local and national companies with waste rubber. As I said, we've got over 90 verbal agreements in place with many more in the pipeline. For them, they'll have a cheaper and a more environmentally friendly recycling process. They can see the benefits of reducing their own carbon footprint. We'll be helping them to fulfil their statutory obligations, and we'll provide them with a cheaper and more environmentally friendly disposal service. In terms of our educational links, well, we already have links with Northumbria University and Cardiff Universities who are interested in further research on our products and in developing educational links, and we hope to develop links as well with your colleague Sunny, who's here today. In terms of cement, concrete and rubber product suppliers, well, I think they will all see the benefits of increased quality of our product, the reduced waste and storage costs, the possibility and potential for opportunities of closed-loop recycling, and reducing their own carbon footprint and also saving them and making them money. Our key stakeholder is the environment, and I hope through what we're saying already you can see that there are major benefits to the environment of what we're proposing. To finish off in terms of how you can benefit, So we can provide you with a high-quality range of rubber products, powders and granulates, high-quality steel, high-quality fibre and textiles. Our rubber products will be 99.9% pure, better than much of what the industry is using at the moment. And as I'm sure you know already, concrete is significantly stronger with rubber crumb added. It is more resistant to freeze-thaw, less likely to crack, has enhanced durability, longer lasting, and means less need for repair and maintenance. Our rubber products will be cheaper than virgin if you're buying virgin, and provide a better value for money than any recycled rubber products you're currently using. And our MRP products can form up to 30% of your concrete mix, making your mix cheaper at production stage, reinforcing it, helping it to last longer. It'll have increased elasticity, less likely to crack, with added insulation properties, making it, helping it to reduce noise pollution, heat loss, and improving water resistance. We hope that you can see both the commercial and environmental benefits to our products and what we propose, and how they can contribute to an improved quality of your own products and assist you in your own sustainability targets. And we hope that we'll be able to talk to you further about developing some commercial links. And right now, if there's no immediate questions, I'll hand over to Dr. Allen for the technical part of the presentation. Okay. Thank you very much, folks. Thank you.
I only led the clapping in the hope that I might get a round of applause at the end. Take note, this is the Northern team. Stephen's from Middlesbrough, I'm from Durham. Professional, not prepared. Notes, none whatsoever. How do you think this is going to go? I've got no notes. It could go anywhere, couldn't it? If I got quiet, leave me for a while, because I'm probably thinking what to say next. I get paid for this, isn't it? I get a great job. Right, just a little thing from Steve said there. He said, increased strength with rubber crumb. Be cautious on that one. If you put any soft material into a concrete mix, if you put air into a concrete mix, as you guys know, you'll get a strength reduction. Right? There are other ways of measuring durability, performance, name it what you will. I just came to mind, just when you said that. Just when I get to that, you go, oh no, what's you talking about this for? But that's it, yeah. Anyway, a little bit about myself first. Alan Richardson, in the flyer, it says, Professor Richardson. Oh, you see, that's how I got you down here. You know, I was a doctor this morning, I'm a professor this afternoon. Wow. I've informed the HR department the pay increase will be next month. A guy reliably told me this. 20 grand a year just for one performance. It's marvellous. Right, Alan Richardson. It's like Mr. Brown's boys, this, isn't it? You've seen that one. So, just a little quick background. Took over the family business when I was 21. It was managing director straight away, so I didn't have any career pathway, I just leapt straight into it as the old fellow died. It was established in 1850, so it wasn't a flash in the pan construction company. We did hospitals, we did big housing projects. And then I was out of the frying pan in the fire, you might say, 21-year-old. Boy, I can learn to work very quickly. And at least get it 80% right. 99.9, as I heard there, that's fantastic. 80% generally gets you through in this life. So I had 26 years of that as an MD, doing construction projects, knowing the value of a USP, a unique selling point. What's this got to do with rubber crumb? I'm not here to sell it to anybody. It can be anything you like. The concrete industry, in my opinion, if we get past the first slide after half an hour, you'll be doing fine. The concrete industry is probably one of the only real sectors that's innovative, that's honest, that, I know, I have to say that what Concrete Society means, that's honest. Was anything professionally, whatever it was, dodgy, talked? No, it wasn't. You put it in the minutes every time, but it is, because you see problems and you deal with it. You put an extension on to Heathrow, so you put a rail line in to deliver the cement. You say, I'm a member of the Concrete Society, and I think it's a fantastic place to be. I think it's fantastic to be with these people. You use rubber crumb in the manufacture of cement, part of the concrete industry. And this is getting rid of waste, this is saving fuel, this is maybe increasing the thermal capacity of whatever it is to make it work quicker. Which one was mine, by the way? That one, isn't it? We could be drinking that, if anybody doesn't make a difference. Just a little thing before we get started. This stuff here, okay, that's the tyre casing, am I right? In the outer tyres, which has got nothing to do with this, but as you're here now, and I've travelled all this way, I'd like to talk about it just for a minute. But this go anywhere, you never know, do you? Anyway, that's amazing. I've just met Sonny here for the first time ever. And we said, what do you do? He said, well, we work in the building environment. What do you do? Oh, we do structural design. Oh, he said, what's the value you use for steel design, say, on columns, with reasonable thick flanges, because I know that makes a difference. Say, 16mm flange. Newtons per square millimetre?
Yeah.
What would you say, roughly, a value?
Of what?
Of the actual characteristic strength of the steel that you use for calculations?
It's about 500
It is.
it's actually 400, 200 and 600 in Europe, but here in the UK we use 500.
500. But if you get thick sections of steel, you reduce that, don't you, because of, for design purposes. 500, let's go with 500, it's a nice round figure. When we tested that stuff there, we got a value of 2,000. Now, I've done work with resin bars, and we got some great values, tremendous values, plastic bars instead of steel. But when I rang the manufacturer, he said, it's because it's a small bar, you get a much higher value with smaller bars. I didn't know that. That's a very fine fibre. 2,000 megapascals instead of 500. 4 times as strong as the normal steel we would use from tyre casing. That is amazing. We had a little chat before. I did some work presented at the conference in Prague. When you put a bolt fixing up there, all around us, bolt into concrete, it's not reinforced. You're kidding yourself if you think it is, unless it's next to a steel bar. It relies on the tensile strength of the material to support it. If you put those in the concrete, I tried this test. The only reason it didn't work, we didn't finish this conversation, the only reason it didn't work was the glue failed. The glue failed. Because I did a paper with steel fibres, polypropylene fibres, and you get a bigger pull-out cone, so therefore you get a bigger pull-out value. If you put this in, hang on, steel fibres, Tronics fibres, 1,000 MPa, 2,000 out tyres. Hey, come on, the bell should be ringing here for me and my gal. Reinforce the concrete around that, huge pull-out values. You're reinforcing the concrete between the steel bars, out tyres. That's one test I want to repeat. It failed because of the glue. It was sold the wrong glue. We did it again, it still failed. It wasn't the fibres in the concrete, it was the glue. Now there's a chap from Northumbria University, forgive me if I get the pronunciation wrong, Pilatalpis, I think his name is. Is that how you pronounce it? Pilatalpis? Yeah. Right, okay, that's a hard bit over. He's got a patent on this, right? However, that doesn't stop other people selling it, right? I don't know what the patent is about. You need to check that out, right? That's a phenomenal material. I met a guy called Tillinger in Denmark. It's one of the best conferences I ever attended. We finished the conference, bottle of wine. We had the first course, bottle of wine. You get the general drift here? Yeah. Right? By the end of the night, everybody was your friend. Oh, what a conference. This is academia, love it. Thank the Lord I'm not contracting anymore. Right. Tillinger. And he put some insulation in a school in the Himalayas. He built it from local materials. This guy was amazing. He was Dutch. Yeah, Alan, yeah, we just got them out in the guild. Yeah? Need to know him. Yeah. There was an architect with him. I said, where are you from? He says, Norway. And I looked at it. From Norway? Big hook in the walls, dark skin, Norway. Yeah, but the family's from Peru. And they use natural materials as well. I got on like famously with them. They use tyre casings for insulation. Absolutely amazing. At 10, 15,000 feet in the Himalayas, the sunshine kept this building warm and didn't need anything except natural heating. Fantastic work. Awful tyres. So there's two, we haven't even got the one I came to talk about yet. Right, which is called Crumb. I was going to tell you a bit about me, wasn't it? Yeah, we'll get there eventually. Is anybody in rush tonight? Forms to go to? Well, okay. So, 26 years as a managing director, and look for a unique selling point. The industry, or the business these days, and it is a business, right, and I think one of the reasons it came down here is when I spoke to a guy, I thought, this is a man who works hard. This is a man who sees a commercial venture and says, I'll give that a go. And by God, it takes a lot of effort setting up the whole process as he's doing. But if you've got a USP, one of the things I remember when I took over the family business, 21-year-old, why are we not making money? I'll tell you why. We work for architects who've got the lowest price. So your estimator had to go in at suicidal rates almost to get the work. Even though there was lots around, there was no need to do it. Find a different way of doing it. Find something unique. Find something different. Do that. Make some profit. Because profit is not a dirty... If you've got profit, you can treat clients like the king and queen because you've got a margin in there. You say, well, if you want that put in, like, no problem, we'll deal with it, leave it with us. If there's nothing there at all in there in terms of profit, how on earth can you take that attitude? Because bankruptcy's on the cards straight away, right? This might be a product that may not give you a huge performance-enhancing material because concrete's conglomerate. There's lots of ways to enhance the performance. It may not give you the most sustainable way to do it, but it'll give you something. Put all this together, it might win you the job. Because that's what you're all about. You're about selling. You've got to win a job. You've got to sell a product, you've got to sell it to a contractor who sells it to a client, and so on. This could be one of them. This is an area which I would like to see developed. Now, when you see the PowerPoint, there are other areas that, or other people who take patents out on this. I'm not so certain it's a good idea to take a patent out on concrete. You know, did the Romans do it? Is the Pantheon still standing? Yeah, it's been around a long time. And as a cousin said to me when I started my PhD, which I was late in life, coming back to education, very late in life, he said, concrete, what on earth can you study about concrete? There's nothing to it. It's just water, cement, aggregate, throw it together, concrete. And you know, it's true. It's true. And a fool can do it, and it can set. But doing it well, oh, that's a different game altogether. But the way you guys do it these days, scientifically, as physicists, you create some very specific materials. This is one which certainly, in my opinion, needs a lot more looking at. Now, I'll not jump too far ahead. No script, just as it comes, right? Let's see. So let's move on. Let's see if I can get this thing to work now, shall I? Left click? Right click? We'll see. Let's try that. Nothing? Just a minute. Which one do we do on this one? Or this one? Send it. Oh, this is a keyboard? I'll tell you that. Probably right. Okay. Right, let's just make certain I haven't left too far. Before we start, right? That's where I work. Lovely set of bridges, fantastic. Wonderful engineering heritage in that part of the world. Cold, man. We've still got snow up there. I saw a man here today with his shirt off. And we've got snow back in Durham on the hills. Oh, I need to move south. That's the love of my life, Durham Cathedral. That's my city. I know the man who maintains that building. I'm very privileged to know him. So I'm very happy there. Probably won't move, despite the fact that the weather's clearly better down here. And we're going to have a look at Robert Crumb in concrete. But before we do that, because I wouldn't like to leap into this, I said leap. Right, this is the book which I've just put together recently. My chapter on this was the reuse of products and materials in the construction industry, but I particularly looked at concrete for my contribution to the book. I was at a conference in Egypt 3 years ago. I went in November, went out there, the weather wasn't too bad, swam in the swimming pool, came back, there was 3 foot of snow in the car. When I was at the conference, I said to the chairman, or chairperson, it was a woman, Iman, lovely woman, I said, I feel a bit of a fraud coming to Egypt to talk to you about freeze-thaw protection using rubber crumb in concrete. And she said, no, we get freeze-thaw problems up in the hills or wherever it is. I said, well, that sort of justifies my trip to Egypt, doesn't it? But the wonderful thing about it was that she was a wonderful woman, right? Fabulous woman. I said, I've just had an offer to write a book. I got the email when I was in Egypt. And that was the time. It's off for the publishers now. And she said, is anybody doing steels? I said, no. She said, you wouldn't mind that. So she did her chapter on steels, which I incorporated in there. Oh, it took some reading, I tell you. Very technical, very knowledgeable, marvellous. Privileged to work with her. But she came up with this statement. And this isn't mine. She took it from Jacobs in 1969. What a far-thinking person that was. 1969. The cities of today are the minds of tomorrow. That's what we're dealing with. When I was coming here today, which I could have run faster when I was younger, from London, central London to Chelmsford, right? Good on, I promise you. Guy and I were talking in the car. I said, when I was a child, in our village of about 1,000 people, 2 people had cars. 2. There were still wholesome cars. Dear, does this age me somewhat? Right? Still wholesome cars. 2 people. Is he going to make any money with 2 people with cars? Not a penny. Now every house has 2 cars. Am I right? Yeah. And that's why what we've got now is a massive amount of waste products. Massive amount. Right, lovely a one-off. I stole that from Iman in Egypt, and I thank you for that one. Right, what do we do with all? You know, look at it. I'll tell you what we do. Next to my golf club, there's a place called Envirotech, or whatever it is, and they grind up rubber and they make carpet underwear with it. Right? Lots and lots of carpet. I'll take some stuff from them and do some testing, rubber crumb. It's mechanically ground, it's not nitrogen, it's just a straightforward mechanical process. Quite reasonably clean, and had a fire there. And that's the sort of scale, and it burned for 7 or 8 months. Fire brigade stood and watched it and said, nothing we can do. So that's how toxic that was. We played golf in amongst this, so everybody had coughed for about 3 months. Nobody stopped playing golf. I probably went up and go to work. I mean, that would have been dreadful, wouldn't it? You know. Huge problem. Huge problem. Farmers have used it for silage. That would get used again in another country. But you have to watch it because some of the tyres from other countries have different blends of rubber ratings. Some strange old materials, which we'll look at in a second. Now, what do we do with it? Well, this is one of my passions. Everybody knows what that is? A motorcycle rear wheel on a tyre. Now, that means wussy, right? So I was explaining the left boot, I'm a 61-year-old, my left boot is torn away on the front with the crank hit round corners. But these things shred like fury. I can shred one of those in about 2,000 miles. When I was younger, I could probably do it even quicker, right? Because the 4 bits, you've got a full throttle on the thing. There's a lot of motorcycles here, there's probably a lot of deaths associated with it as well. But I couldn't resist that one. And next time we're in the car park, just look at that edge. There. That's the bit that says, is he any good or not? Right? Sensible? No, goodness. He's only just starting to get sort of on the fun game on that one. Right. Rubber crumb, we'll get there. Tyre problems. Okay, we've got 1 billion tyres manufactured annually. That's, I'm not certain, this is what Watson and Brown said, so you'll get conflicting views on this. Because every time I read a paper on what's the CO2 content globally from cement manufacture, well, it started off at 3%, then it went to 4%. Now, I don't know what it is really, to be honest, but it's a substantial amount. And maybe that's a substantial amount of tyres as well at the same time. Natural rubber, well, you know, there's a limited amount of that that comes from trees. So there's an awful lot of tyres worldwide which you have to do something with. Now, I'm very privileged to know this guy, Kevin Payne. When he was at Dundee University, he did some work with Ravi. Hang on, Ravindra. Come on, who's your president? Ravindra Dear, that's it. Goodness, thank you for that. That's a joint effort, this. It makes it sort of, keeps us all together, you know, bonding. Right. Anyway, Kevin's a potatoes expert at Bath Uni. He looked at that, and he found that, yeah, it gives it a little bit of freestyle protection. He looked at other aspects of it. You get different strain capacities in that. So that was Kevin Payne to start with. These guys here looked at rubber Crumb with regards to freestyle resistance, and they said, yeah, it sort of works, but to what degree does it work? And I wanted to look at something extra, because there are different types of rubber Crumb manufacture. There are different types of rubber Crumb sizes. You guys in the Concrete Society know that if you want air-entrained concrete, then you want void spacing or pore spacing at quite specific intervals at a particular size. This rubber Crumb's right on the limit of your maximum. It's almost like entrapped air size. But there's more to it than that. You see, my PhD is in concrete with microfibres, type 1 microfibres. And when I did the viva to defend my PhD, the guy said, it's got lower density. I said, yes. He said, it entrains air. I said, no, it doesn't. There was a silence. I thought, oh, this PhD is going to go down the tube here. He said, well, the density is lower. It must be air entrained. I said, no, it's not, because I've done an air test on fibre concrete. There is no extra air in that. What happens is, I'm telling you this now, and I'll tell you the lie I told afterwards, right? What happens is, the fibres, you've got lens water around the fibres, and when that evaporates up, these tiny little voids. Oh yeah, air pockets, we call them pores, but it's not air. It's the evaporation of the water that does it. So when I realised I wanted my PhD, am I a man of ethics? Like hell, I just said, yeah, it entrains air, no problem at all, give me that PhD. Right, and I got it. See, that's shocking, isn't it? Ethically, absolutely appalling. I'm cheap, I throw it away. Right? Rubber entrains air, it does. Because of the shape, and if it's not entraining air, it's the water with the surface tension around the particles that's causing little voids. Oh, let's face it, you've got a tiny little void, you've got a compressible material, that's got to be good in terms of freestyle protection when you get pressure building up inside the material. Right, so, there's only another 350 of these, we'll get on with it. Okay, the method of freestyle protection identified by Kalu stated that due to the non-polar nature of the particles and their tendency to entrap air in the rough surfaces, the tire rubber concrete specimens contain higher air contents than plain concrete. I would agree with that. I think it's other things as well. I think he's only told part of the story there, right? But they also repel water, you know, because it's got silicone in, basically, lots of it. So I think we're on the right track, but there's a little trick we're coming to on that one in a minute. The patents, I'm not so certain whether you can patent this successfully, to be quite honest with you. And would you want to? Think of the cost of a patent when you could sell it to a client who wants a particular product with enhanced physical capabilities that rubber Crumb will provide.
Rubber Crumb in concrete maybe.
Ravindra Dev would probably be the one to go to on that one, but I don't know, truth. I think any soft material, you've got to waste it. The wonderful thing, this is like the wonderful thing about tea, is it? Okay, is that you've got people with active imaginations. Now, my research currently is bacteria in concrete. Why did I do that? Because I met a man in Bath who put me in touch with a man in Delft, who put me in touch with a man in India, get around a bit, and we talked about it and it works. Calcite formation. Why would you do that? It's almost crazy. You've got all these waste materials. I've tested recycled concrete, recycled construction demolition waste. I've tried it washed, unwashed, graded, selected. I think it's just another one of those things that you say, look, that's a great big pile of rubbish. Can we do something with this? Please. Look, you can't just leave it. Well, the farmers were very good, because farmers are very canny. Very canny means economic, I think is the word, right? Okay. And they use them to compress silage, because they're heavy, especially white. Very heavy. So why would they do it? Well, we know iron treatment works, but you know something? That's Powers and Bromyard, if I remember rightly, where they did work on the freezing bottle effect and lens formation and this sort of thing. And that was only in the 50s, if I remember rightly. It was 50s. So really, we've only had 60, 70 years of real technology with concrete. Prior to that, it's back to the Roman times. Vitruvius, you put so much volcanic ash in, so much Roman cement, this, that, and the other. Oh, yeah, you got it right. That lasted 2,000 years. It's still there. Does anybody will testify from Rome?